Okay, let's get started with solving trig equations. Okay. So now we're just trying to solve. There's a couple different ways to do it. You can be solving within a set interval, or you can be solving general solutions. We're going to start solving within an interval because it's just easier to understand. So all of our answers for this front page need to be between 0 and 2 pi, but it cannot be 2 pi though. All right. So now, what your end goal is actually for what number 1 looks like. That's what you want to do. Because if you look at some of these problems, like they're not set up where it's like super easy to tell what's going on. This is your end goal. You want it to be something like some trig function equals some type of number. You want that. Bless you. So, when does sine equal a half? And this is going to be in radian mode, by the way, because it's between 0 and 2 pi. If it was be between 0 and 360, then you do degrees, which is probably never going to happen. So at pi over 6, there's actually another solution. What else does sine equal? Can't be negative because it's not inside this guy right here. Pi is in the answer. Very good.
11 pi over 6.
That's negative half.
Hold on, give me a second. Someone give me a unit circle. I wish I could pause time and like get the answer and then like on with who's away. Yeah.
Is it not 5 pi?
Or like pause it and then look at my notes. I'll take the quiz and then go back. Yeah, that'd be nice.
When does sine equal a half at 2 spots in the first quadrant and the second quadrant? 5 pi over 6.
Wait, isn't that what I asked you in the first and second quadrant? Yes.
Yeah, so sine is positive in the first and second quadrant. So the answer is going to be pi and 5 pi over 6. Now this is different from arc sine. I'm not asking for arc sine. Okay? I'm just asking when does sine equal a half. If I ask for arc sine, then that's when the domain and the range change. If I'm just asking you, hey, when does sine equal a half? And the answer is going to be between this and this. This is how you answer it. Okay? So the notation that I use, because I'm here not to confuse you, is just this. I just get here and we just play our little old guessing game, or hopefully it's like I have the knowledge and not guessing.
Do we need to know the
Yes, you need to know, again, you need to know the whole unit circle.
I know that, but like the intervals, like for each thing. Do we need to know that?
What do you mean by the intervals? Like for arc sine and stuff like that? Is that what you're asking? No.
Okay. So,
Number 2, if it comes to you, just let me know. Number 2, you want to get this cosine function by itself. It's almost by itself, but it's not, so what do I need to do? Divide by 2. So, when does cosine equal negative 1/2 in 2 spots? It's, by the way, it's negative in what? It's negative in what 2 quadrants? 2 and 3.
But we can't use 3, so we stop.
No, this is not inverse. This is not inverse. We're not inversing.
You can use all the quadrants when you're doing this, right?
Yes, you can use all the quadrants. If you're solving an equation, you can use all the quadrants. We're not inversing, we're not arc cosining, that's not it. We're just trying to solve for x.
This is what confuses me. Now I know 2 things. Now what am I going to know?
I know, I hate when I learn 2 things.
That's what I meant. Okay, whatever.
Okay, first off, when does cosine equal a half just in the first quadrant? In the first quadrant, it equals... When does cosine equal a half in the first quadrant? Pi over 3. Okay, so I want pi over 3 in what 2 quadrants now? Second and the third. So what are they? I heard one of them. So again, it's really helpful to know that, have that unit circle memorized. I think I've said that since we started learning it in December. Memorize it. How's your finger thing that you use? Does it work?
It works, but like not when it's that bad. Because the fingers, like I would have to like hold it back.
Hold your fingers.
Yeah, because this only gives me the first quadrant once, and then I can just copy it over.
How come you can't rewrite like cosine x equals negative 1/2 as cosine to the negative first of negative?
I know what you're saying. You can, but the only problem is then that gives you a restriction now as soon as you do that. So that's the reason that we don't. That's the reason I don't. I'm just trying to help you from confusion. Because on your calculator, you totally could do that, and it's going to spit out this answer and this answer only. Your calculator will not spit out multiple answers. So that's why on the calculator, you always use the inverse thing, and then you just go from there. Okay, number 3 is tangent by itself.
It's squared.
So how do you get rid of a square?
Square root.
So we're going to square root it. What's special about square rooting a squared?
You get the normal.
Get the normal. Yes, okay. Not what I was going for.
That's true.
Fine, but what's special though? Someone said it.
They go common this here.
Somebody said it! Louder!
Plus or minus 1.
I think you just took credit. No. Good job, Gabby. Proud of you.
We're stepping up. What?
Say it louder next time. Okay, it's plus or minus 1.
Square root. Why do you do plus or minus when it's square root?
That's a great thing. I'm going to go off on a tangent now. I love it. I love it. Oh! That was done on purpose. I'm trying to get it there. This is too odd. Alright. So if we have x squared equals 1, okay? We good? When we take the square root of that, the definition of a square root of a squared is absolute value. Did you know that? If you square a square root or square root of squared, it becomes an absolute value. So the absolute value of x is equal to 1. The absolute value has 2 branches, a positive branch and a negative branch. So this would become...
The value is negative. That's the point. So what happens?
For what? Yeah, if the absolute value is negative, then that'd be imaginary. Because you would get a negative underneath the square root. So that can't happen. Okay. Good talk. Alright, so this is why you always get a plus and a minus whenever you square a square root. Okay? Because you square a square root becomes absolute value, and the absolute value has 2 answers. It has a positive answer and a negative answer. We cool? Tangent over. Do we all enjoy that? Just say yes, lie!
Yes!
Thank you.
You could call me on and say, oh, I don't lie.
You don't lie?
No.
You've never lied in your life?
Nope.
Not even to your parents?
My parents?
You're on video, so probably you're...
Okay.
Okay.
That's not a lie.
Oh.
That's just the truth. Until they...
Alright, this is a moral dilemma, is stretching the truth a lie.
But then you're protecting someone. Until they find out you're stretching the truth, and then it becomes a lie. You get around it. What were you stretching? Oh, I'm
Okay, so when does tangent equal 1?
0.
5 or 4?
And
5, 5 or 4. When does tangent equal negative 1? 0 is not an answer. I'm just going to warn you, at WebAssign there'll be questions like this, and it wants you to have a pi in your answer. So for those of you that whip out your calculator and start typing in pi over 4, and you're like, I'm not getting the right answer, it's because it wants the answer in pi, in terms of pi. Unless it specifically says round to the nearest whatever decimal, you don't ever write decimals on WebAssign. Got it? So this one's going to want an exact answer. It's also going to want you to list these in from smallest to biggest. So let's go ahead and practice that right now. So my final answer, listing from smallest to biggest, is going to be
pi over 4.
boom.
3 pi over 4.
Boom.
5 pi over 4.
I think we got the idea now.
7 pi over 4.
At least one person does. Alright, so that's how I want you to write your answers, just from smallest to biggest. If you don't, will I mark you wrong? I can't, but will WebAssign mark you wrong? It's a computer. It can only do what it asks you to do. It will. Because I like it.
I don't like it. What, like, what is, why are we,
The stuff on the
what are we
website
doing
from
it
today
instead
and
of,
next
or are we doing it
class,
as
Yep.
quiz class.
We're doing it instead of.
It's from the next couple of days, so you really can't start working on it yet. You can start working on it for a couple questions, but not for all. Okay, next one. Ooh, this looks fun.
Not really.
Okay, let's get all of our signs together and everything else on the other side. So what can I do?
Well, if you divide by sine, you get a -1.
Yeah, but then you're going to get root 3 over sine. That's no good.
Add sign on both sides,
No.
Add sine on both sides.
so that we can get our sign.
Then you get 0.
Try again. Sine plus sine.
1.
Try again.
No, 1 is negative and 1 is positive. So they cancel out.
Nope, it was positive.
What?
You're going to get 2 sine.
And the other is positive.
Sine plus sine is 2 sine.
You're adding those.
Oh. See, I was doing it the other way. But then you have the Trig there. Why don't you just subtract the other side?
You get negative.
Yeah, why don't you get -2 sides?
It works both
And the
ways.
negatives cancel each other out. Yeah.
Okay, so we're going to...
Sine equals √3. See, I got there a lot quicker than you did.
So 2 sine equals root 3. Get sine by itself. You're going to get sine of x to equal root 3 over 2. So x is going to equal
Pi over 3.
pi over 3. Nice. Really need to know that unit circle.
Is this what we're doing all classes?
Yes, this is what we're doing all class.
I feel like we get this point, right?
I mean, I can just like stop and give you the assignment.
Are we doing something else?
Unfortunately, I think all these are important. Like, they're all different in a way where I don't feel... Like, some of these, I'll start skipping some of these. Okay. Alright, next one. The tangent one. How do we get tangent by itself?
You add.
Actually, why don't you try this one by yourself? Try it by yourself. So if you're watching this on YouTube, please hit pause now. Okay, so to do this problem, what's the first thing you all did? Add 1. Boom. 3 tan squared x equals 1. Then what? Divide by 3. So you're going to get tan squared x equals 1/3. Now what? Square root each side. So you're going to get tan of x equals plus or minus square root of 1 is over square root of 3 is just square root of 3. Does this look familiar? This is the same thing as plus or minus root 3 over 3.
Wait, what?
It's called rationalizing right there to there. It did go on the 1. Square root of 1 is 1.
Okay, but. Okay, but just leave it as 1/3. That's 1/2 divided by 3 over 2.
Yeah, but tangent doesn't do anything for root 3 over 2. We don't know that.
Yeah, it does. Yes, it is. So we divide this, and then the 2 goes away, so it's 1 over root.
I don't know what.
I'm lost on what she's... Okay, I'm not the only one. I don't know what you're saying.
What do you mean?
What do you mean?
Oh, what do I consider now? It makes sense. Okay, how do you get 1 over root 3? You divide 1/2 over root 3 over 2, and then the 2.
Oh, I see what you're saying.
Okay, please explain it to me.
Okay, so instead of rationalizing 1 over root 3, you can rewrite it as 1/2 over root 3 over 2.
Or you
And that helps her
that's what that
understand where she's
equals.
looking on the thing, because she knows tangent is sine over cosine. So she's looking for when sine is 1/2 and cosine is
Wow. That's why you're going to be a good teacher, and I'm terrible at it.
Yeah, so
That's how I solve it.
Alright, I like it.
You don't have to rationalize it. You can actually say.
Well, I don't rationalize it. I just try to help people out. Alright, so I will not name this student on the video because that sounds a little rude. Huh? This student did this. She's like, oh, well, it's 1/2, the same thing as root 3 over 2. She did this, so she realizes that on the unit circle, she needs to find the 1/2 in the root 3 over 2. So when sine is 1/2 and when cosine is root 3 over 2. But this is also plus and minus. Since this is plus and minus, how many answers are we going to have? 4. We're going to have 4. So I'm going to name 1 in every single quadrant. So when does that happen in the first quadrant? 5 or 6?
Yeah.
Second quadrant?
5 pi over 6.
Third quadrant?
7 pi over 6.
Last quadrant? Fourth quadrant?
Pi over 6.
Got it?
So if it's plus or minus, it's always going to have an answer in every quadrant.
Unless you're going to get zeros, like if it's like a quadrantal angle. So like sine of plus and minus 1, sine of x equals plus and minus 1. Not going to give you 4 answers. Because sine only equals 1 time in a full cycle, and equals -1 one time in a full cycle. So as long as it's not a maximum or a minimum value, yes, you're going to get 4 answers. Okay, secant. Now, I don't like secant, but I do like its good old sibling who? Which is 1 over so 1 over cosine equals -2. Happens when I flip each of those. What happens? Cosine x equals -1/2. Didn't we just do this problem? So here's a trick. You just got to get from here to here. Any questions going from secant of x equals -2 to cosine of x equals -1/2? If there's 0 questions, I'm literally just going to copy down the answer here from number 2 because it's the exact same thing. Alright, here's a weird one.
Whoa. Hold on. I have to write this down.
Okay, fine.
Okay. We can move on.
Alright, let's move on. I'll do this in blue. Okay. This is a weird one. What's your instinct tell you? Yeah, you can't do that. You can't divide by functions, because if you divide by functions, you can get undefined functions, so you're not supposed to do that.
What?
So can you,
Okay, so since we cannot divide by trig functions, we have to get them all on the same side and factor one out. So I'm going to get this 4 cotangents on the left-hand side. So we left with cotangent x, cosine squared x, and I have to move this over by subtracting it.
Wait, what?
Okay, so you need to get it to equal 0.
now can you factor it?
Now we can totally factor it. How does this factor? So take out a cotangent x, and I'm left with just divided it out, so it's going to be just 4. Okay, so now I have 2 different problems. I have cotangent of x equals 0 And then I also have cosine squared x minus 4 equals 0. The cotangent x equals 0 one is much easier than the right-hand side, so let's do that one first. When does cotangent of x equal 0? This is also the same thing as cosine over sine. So if this helps you, this is cosine of x over sine of x. When does cosine equal 0?
0.
At 0, it's 1.
Pi over 2.
Pi over 2. Anywhere else?
Yeah, the other one opposite of that.
3 pi over 2. Okay? Are we good for the left-hand side there?
Wait, hold on.
Alright.
Hold on. Let me write this down.
Factor again.
No, I wouldn't factor again. Okay, on the right-hand side, we have cosine squared equals, or minus 4 equals 0. How?
You do cosine squared x equals 4 because it moves over and makes it positive. And then you square root it and it's plus or minus 4. Cosine x or 2 plus or minus 2. And
When does cosine equal 2?
I have no idea.
Someone said it, what? Never. When is it equal to negative 2? Never. So over here, there are no additional solutions. So the only answer is those two right there. Okay, what about number 8? Any ideas on how to do number 8?
Subtract.
Just like the last one? Perfect. I like when we recognize that.
And then you take sine out. Then you take one sine out.
Okay, we're going to just pause it right here. All we do is move it over because we're going to want to factor it. That's the whole point of this. We want to factor it. Just like when you have like a trinomial. You all know what that is, right?
No.
Like x squared plus 2x plus 1 is a trinomial. You want to set it equal to 0 so you can solve for it. Okay, so now we can factor. What does each term have in common?
Sine.
So I'm going to divide that out. When I take out a sine from sine squared, I'm left with a sine of x minus 2. We have two separate things. So we have when sine is equal to 0, and when sine minus 2 equals 0. I agree with you. Let's go in order though. So what's the smallest value? 0, and then why am I not including 2 pi? Interval only goes to, but not including, 2 pi. Okay, what about this side over here? What do I do to solve for sine? Move the 2 over. When does sine equal 2? Never. It never does. Alright, I'm going to just try to find some problems that aren't repetitive. Okay, I'll do 9 and 11. Okay. For number 9. Because it's new. Get used to it. For number 9. We have 2 sine squared minus sine minus 1. Can I factor this? Let's factor it. Okay, so what's the only way to get sine squared? Sine times sine, right? How do you get a 2? One of them has to be a 2 sign. How do you get a 1? How do you multiply to get a 1? 1 and 1. I know. I feel the same way. All right, and then how do you get a negative sign?
A negative and a positive.
A negative 2.
I agree, but which way? Which one's what?
A negative 2 and a positive 1 for the negative.
Like that?
Wait, why?
So that the negative 1 will multiply with the 2, and the positive 1 will multiply with the 1.
Wait, what? It's okay, we know it's right, so but don't you want sine to be negative? Don't you want it? I don't get it.
Because if you multiply the negative 1 times the 2, you get negative. Please. Enjoy yourself. You get a negative 2 sign, multiply this in here, you're going to get a 1 sign. So negative 2 sign plus 1 sign is a negative sign.
Oh, okay. Yeah, I get it now.
Are you just saying that so we can move along?
No,
Oh, okay.
No, because I was confused. Yeah, I was really.
Okay. So we got to set each of these equal to 0. So we're going to have 2 different equations. I'll go a different color again on this one. So we're going to have 2 sine of x plus 1 equals 0. And we're going to have sine of x minus 1 equals 0. On the left one, how do I get sine by itself? Yeah, but let's subtract 1 first. And then you said divide by 2? When does sine equal negative 1/2? This means we're going to be in the third and the fourth quadrant. It's got to be between. What is it?
Oh, wait, yeah.
No, it's not over 3. It's going to be.
Pi over 6.
And
The
the other one. Yeah, write that on your test. See how that works out. The other one.
Hey, but you know what I meant.
Do you get partial credit for saying the other one? Maybe. I'll go a half point. The other one. Alright, so it's all for sine on this side. All you have to do is add 1. When does sine equal 1? Pi over 2.
Pi over 3.
And that's it. So let's put this in numerical order. Let's pretend we're web assigning it. How do you put this in numerical order? Which one's the smallest one?
Pi over 2.
I like how y'all knew that.
The next 7 pi, yeah.
Okay. Okay, so just giving you a heads up, 10's like the same thing, just different numbers, so we're going to kind of skip through that. Let's go to 11. Okay. This one looks confusing, but there's a trick that's always going to apply here. So you have 2 sine squared plus 3 cosine of x minus 3 equals 0. They need to be the same trig functions for us to factor this, but they are not. You have a question?
I'm not doing this because I'm lost.
Okay. I need to get these to be the same trig values in order for me to factor it, like the way I just did. I know I can't change cosine. I know I can't, because I know my trig identities.
Because you have to have a square.
Yeah, you have to have a squared, so what can I change?
Sine.
How can I change sine?
You can make it multiply by each other. Nope, you can do that. Is what I meant. Oh, you can do that?
Totally legal. That's why we learned it. So we're changing the sine squared into 1 minus cosine squared. Now we have to just rearrange this and have a little bit of fun. Should be that.
Yeah, so fun.
I mean, it's fun for me, but what do I care about you? This is all on video too. I'm in trouble. Okay, I distributed the 2. And now what's another good step?
Take the 3 on the other side.
Combine the 2 and the negative 3.
Okay.
Now, I like what you said.
Negative 1. And then put the negative 1 on the other side.
Why?
Because Make it positive.
Okay. And then?
It's just sitting there. Then you divide with the other number. I don't know.
I can tell. Hey, let's divide everything by -1 so we can get the leading term to be a positive.
What?
That's legal. So it's 2, because it's an equation, you can do that. Now are we ready to factor? That took what, 4 steps to do? It just is what it is.
Okay, wait, hold on.
I couldn't be holding on anymore.
Oh, so you just divide by the negative count. The -1 is very positive, but it stays there, right?
Yes. Now what?
Wait, I think I did something wrong.
Okay, so it has to be this, right? There's no other options, just our signs have to match up nicely. It has to be 1 and 1 on the right side, it has to be 2 cosine on the left side. And they need to be the same sign. And it needs to be a -3 cosine, so if you minus. Okay? So I need this to be 2 cosine of x minus 1 equals 0. And then you need cosine of x minus 1 equals 0. When I factor it, the 3 goes away. Because when you expand these, okay, you're going to get 2 times -1, which is -2, minus 1. Yeah. Okay, can I just real quickly say that this is cosine of x equals 1/2? I'm not going to do 13 because it's too repetitive. So x is going to equal what 2 values? Pi over 3 and? I heard someone say it. Someone said it. It's not loud enough. 5 pi over 3. On the right-hand side, when does cosine equal 1? 0 and 2 pi, but I do not include 2 pi. So it's just going to be 0. So in numerical order, this would be
0. Pi over 6, not pi.
Okay, I'm not going to do 12 because 12 is the same trick. You need to practice this stuff on your own. I just want to get through the notes and you'll have plenty of time to practice afterwards. Alright, next stuff is just going to be general solutions, which is not that big of a deal. Alright, nope, this is multiple angles. Ah, gosh darn it. Alright, let me go through it.
That's hard.
It's not hard, it's just annoying.
Wait, what's the difference in the multiple angles that we just did? What makes it multiple?
Not hard, it's annoying. Ugh, what a loser. What?
What makes it multiple angles? Can you just have...
Yeah, so I'm going to go over that real quick. Trust me. So for number 4, I need to get this cosine of 3x by itself.
Oh, I mean multiple angles, so there's a number by the...
Right. The period's different now. That's really what changes. The period's different. Okay, I'm just going to go through 2 of these and then move on. Because there's only one extra step and that's it. The way I teach it, there's only one extra step and that's it. Okay, so how do I get this cosine 3x by itself? Add 1. So far this is not different. You agree?
1/2 equals cosine 3x.
So cosine 3x equals 1/2. Do you agree that this is so far no different?
Yeah.
I'm going to keep saying this until it's different. So when does cosine equal 1/2? So it's when we what? Pi over 3? 5 pi over 3? Okay, so far no different, right? I'm going to make it different now. So
By 3.
divide all these by
3.
3. So when I divide all these by 3, I'm going to get... So multiplying by 1/3 is the same thing as divided by 3. So you're going to get pi over
9.
and
5 pi over 9.
Okay, there is more. I'm just trying to get us to right here.
What? There's more.
There's more.
You have to.
Because there is usually just two answers. Okay? There is usually just two answers, but I changed the period. Now it's going to occur 3 times as much. So instead of 2 answers, you're going to have 6 answers. So we...
How are you going to get 4 more answers?
We'll figure it out right now. Okay, what's my period? Well, isn't it 2 pi over b? So this period is going to be 2 pi over 3. So I just have to add my period to all these until I get no further than 2 pi. Ooh, it's so hard. What if I made this 6 pi over 9? Is that easier?
Yeah.
Let's just add 6 pi over 9. So we're going to be alternating. So what's pi over 9 plus 6 pi over 9? Okay. Let's do the 5 pi. What's 5 pi over 9 plus 6 pi over 9? 7 pi over 9 plus 6 pi over 9. 13 pi over 9. And then let's go ahead and do this one as well. 11 pi over 9 plus 6 pi over 9 is that going to be my 6 answers I wanted? It's totally unnecessary.
Because the number 3, the b value is 3. So our period isn't 2 pi anymore. It's 3 pi.
Okay? Hey, I just want to just get through these. I don't want to be talking too long. I just want to get through these notes, and then that way you have time to practice your own. Actually, I think the practice you have here isn't... I don't think it involves any of this stuff right here. So that's why I just want to just do 1 or 2 examples, and we can revisit it next class, just to make sure that we know what's going on. Okay? Yes, everything I'm going over today is on the quiz. That's why I'm making the quiz on Friday and not next class, so we have time to go over it. Okay, and then here's the last one, just finding general solutions. So this just means I'm not bounding you from 0 to 2 pi. This could really be anything. I use n's instead of k, so it'd be plus pi n and x equals theta minus. Oh, they're both plus. I'm looking at it now. Yeah. One's n 2 pi, which is really stupid, but I won't write it that way. I'm just letting you know for the sake of your notes on the top there. I use n's. The web assignment uses n's too, so I don't know where these notes came from. Okay. All right. So, when does sine equal 1? Where? So I'm gonna get pi over 2. Okay. So for this is always going to be the angle plus the period times n. Alright? So, what's the period of sine in general? Okay. I'm just trying to make this as easy as possible. I agree with you, because it's 4x equals. So it's gonna get changed itself. Just do it the way I'm doing it. So for sine, cosine, secant, cosecant, it'll always be theta plus 2 pi n. This is why it says it's one of these two. It's either k times pi or k times 2 pi. N is just the number of times it can happen. So n's in our answer. Say it one more time. That's going to be just tangent. Tangent, cotangent, and then this one's going to be everything else. Okay? So now let's divide everything by 4. So x equals pi over
8.
Plus pi over 2n. And that's it. That's called a general solution, because sine goes on forever and ever and ever and ever and ever.
You just did it in there?
So the n's in there because that just means the number of times. Like it just means how many times it's going to happen. Okay. Try 21 on your own, and then we'll wrap it up together. Oh, sorry, this is like 2 days worth of notes. So we're supposed to do notes on the quiz day, but felt like you reviewing on the quiz day was more beneficial. It was a short-term beneficial thing. Are you doing this, Daniela, or are you just going to make duck faces at your phone? Do what? Oh, I know what you're saying. Yes. So for 21, you're going to have two answers. Separate equations. I know exactly what you're saying, yes. It only took an hour and 15. This is easier?
This is a lot easier.
Yeah, so we're just sine equal negative root 3 over 2.
4 pi over 3 is 5 pi.
Okay, we divide everything by 2. What I'm going to get? X equals 4 pi over 6, which is 2 pi over 3. Almost had it. X equals, this one you get.
Hey, are you going to get in trouble if you count off?
Nah.
Oh, I feel like it's easier when they're bottom numbers.
Alright. Okay.